Probability is the measure of the chance that a given event, E, will occur. Probability P of E that an event will occur is always given as a ratio between 0 and 1 inclusive. Down here at the gray box, we talked about this in the previous class, that the way you can find probability of any event is going to be take the number of favorable outcomes and put that over or divide it by the total number of possible outcomes. That's considered theoretical probability. In the third paragraph, we have what's called experimental probability. Experimental probability is using outcomes obtained by actually performing trials of the experiment. So experimental probability is found by taking the total number of favorable trials divided by the number of trials. So when you did the rolling dice experiment, and you rolled the two dice 25 or 30 times or whatever the case may be, that was experimental probability. A probability model is a mathematical model used to represent the outcomes of an experiment. So you could use a probability model to create a probability experiment, like perhaps instead of rolling the dice, you could write a computer program on a computer or a graphing calculator to automatically roll the dice for you and then automatically add those together. So this section basically talks about experimental probabilities, and we will talk about when to add probabilities. So this first example is an experimental probability. The graph shows the results of the several trials of an experiment in which single number cube is rolled. What is the experimental probability of rolling a 6? So for rolling a 6, what we want to do is take the total number of times a 6 was rolled, and a 6 was rolled represented by this bar. Looks like it was rolled 10 times. So that's the total number of favorable trials. So that would be 10. We would put that over the total number of trials. So we're going to have to add up each one of these bars together. So the first bar is a 9, and the second bar is a 6. Third bar goes up to 12. Fourth bar goes up to 6. Fifth bar goes to 7, and the sixth bar goes to 10. So when we add 9 plus 6 plus 12 plus 6 plus 7 plus 10, we get 50. And 10 out of 50 simplifies to 1/5. So according to the experimental probability, the probability of rolling a 6 is 1/5. Part B is what is the theoretical probability of rolling a 6. That's when you assume that each side of a die is equally likely to come up. So there is only one side on a die that is a 6 out of the 6 total sides. And so that would just be 1/6. Doesn't have to simplify that at all. So it's just simply 1/6. We can also do probabilities with decks of cards. So what is the probability in a standard 52 card deck of drawing a king? So for drawing a king, there are actually 4 kings in a deck of cards. There's the king of hearts, king of spades, king of diamonds, king of clubs. That's 4 out of the 52 cards. That would simplify to 1/13. The probability of drawing a spade, there are 13 spades in a deck of cards. There's cards ace through 10, and then jack, queen, king. So that is 13 total cards out of the 52, and that would be 1/4. And then the third part is drawing a king or a spade. So how many cards in a deck are a king or a spade? So you may be going back to the first two questions where we discussed that there were 4 kings and 13 spades. So you may want to say that, well, there are 17 cards that are either a king or a spade. But there is one card that is both a king of spade. And if you say there's 17 cards that's a king or a spade, then you're counting the king of spades twice. So there are actually only 16 cards that is a king or a spade out of 52, and that simplifies to 4/13. Events that cannot occur at the same time are said to be mutually exclusive. Mutually exclusive events do not have any outcomes in common. For example, Because it is not possible to draw a card from a standard deck that is both a king and a queen, these two events are mutually exclusive. So let's try to find the probability of drawing a king or a queen. And since they are mutually exclusive events, what we can do is just count how many cards are either a king or a queen in a deck of cards. And this Venn diagram shows that there are 8 of them out of the 52 cards. And that simplifies to 2/13. Just as we shown earlier, it is possible to draw a card that is both a king and a spade, so these events are not mutually exclusive. So notice this Venn diagram has all 16 cards that are both either a king or a spade. The left circle has all the kings, the right circle has all the spades, and then there's an overlap that is the king of spades. So the probability of drawing either a king or spade, there are 16 of those cards out of 52, and that is 4/13. So the addition rules for probability are that if two events are mutually exclusive, like the king and queen, the probability that either A or B will occur is found by adding the two probabilities together. You can do the probability of each event separately and add those together. So for example, you doing it this way, the probability of king or queen would be the probability of king, which is 1 out of 13, plus the probability of queen, which again is 4 out of 52, which is 1 out of 13, and that is 2 out of 13. If two events are not mutually exclusive, that means that they have things in common like the king of spades did. The probability that A or B will occur is found by taking the probability of each individual event will occur, but then subtract the probability that both of them occur. So in the example of the king of spades, so if I'm trying to find the probability of king of spades, let's see if I can draw a little fancy spade here. There we go. Probability of king of spades would be the probability of getting a king. Probability of getting a king is, there are 4 kings in the deck, so that would be 4 out of 52, which does simplify to 1 out of 13. Since we're adding several fractions together, I'm just going to leave it with 52. We're going to add to that the probability of spade. The probability of spade, there are 13 spades in the deck of cards out of 52, so that's 13 out of 52. But then we just subtract the probability of getting the king of spades. And there is only one king of spades in a deck of cards, that's 1 out of 52. So 4 52nds plus 13 52nds minus 1 52nd is 16 out of 52. Which simplifies to 4/13. So if they are mutually exclusive, you just add the individual probabilities. If they are not mutually exclusive, you'll have to add the individuals, but then subtract the probability that both occurs at the same time. So example 2 is determine whether the events are mutually exclusive or not mutually exclusive, then find the probabilities. Tashika's teacher is randomly assigning the students to a day to present their projects. If 8 students present on Tuesday, 5 on Wednesday, and 6 on Thursday, what is the probability that Tashika will present on Tuesday or Thursday? She's not going to present on both days. It's going to be either one or the other. So since she's not presenting on Tuesday and Thursday, we're going to say that this is not or mutually exclusive. And then to find the probability that she performs on either Tuesday or Thursday will be the probability of each one of them separately. So 8 students are chosen on Tuesday, so there's an 8/19th chance. There's 19 total students in the class when you add all the students up. It's 8/19ths that she goes on Tuesday. We'll add to that the 6/19th probability that she'll go on Thursday because 6 students are chosen on Thursday. When we add those together, her probability of one of those 2 days is 14/19ths. Part B is suppose that 1,400 students, 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that the students selected at random take Spanish or biology? So these are not mutually exclusive because it flat out says that there are some students that take both Spanish and biology. So to figure out the probability that somebody chosen is either in Spanish or biology class, we will find the probability that they take Spanish, and that's 550 out of 1,400. We will add to that the probability that somebody takes biology, and that would be 700 out of 1,400. But then we're going to subtract the probability that a student takes both. And it does say that 400 students take both Spanish and biology right there. So that would be 400 out of the 1,400 students. So when you add 550 plus 700 minus 400, that gives us 850 out of the 1,400 students. And that simplifies down to 17/28.